So now I'd like to take a look at forests and how forests have a tendency to interact with the wind. We saw in earlier chapters how forests can be shaped by the wind and have a tendency to look almost like an airplane wing when you're looking at the height of the trees within the forest. And the front edge of the forest, where the wind is hitting it repeatedly, will be quite rounded. And this is because when the wind hits these front trees, it's going to keep them a little bit stunted. It's very difficult on the trees to constantly be battered by the wind. So they're going to be a little bit dwarfed in size compared to the other ones. And when the wind hits a forest, we notice that 40% of that wind will actually enter the forest, and it will slow down as it goes through these trees. And the remaining 60% has a tendency to go up and over the forest. So as the wind starts to slow down when it enters this forest, what we end up getting is an accumulation of soil right inside the front edge of the forest, because as that wind's slowing down, we have dust and nutrients and insect bodies and wings and things like that dropping out of the wind and creating a really, really fertile mound right here, which can account for the tall growth of this one part of the forest. And not only will these trees at the front edge where the wind is coming from, not only will they be shorter, but the trunks of these trees will also be chunkier and fatter and more sturdy as well. And this is because if we look at the growth rings in a tree, what happens is if the tree is allowed to move in the wind, like we don't have it roped off or tied off or tethered in any way, if that tree is allowed to bend and move in the wind, what happens inside the tree is that these rings are twisting and bending and rubbing on each other inside the tree. And that signals to the tree that it needs to start producing this growth hormone, which will help thicken that trunk over time. And so it knows what kind of response to put forward when the wind is battering it on a constant basis. So this is why when you have a very young tree, that you really want to remove the tethers once the roots take hold. You want that tree to be able to bend on its own and get stronger, and it needs to get beefed up in the proper way. What happens when we have the tether on the tree for too long is that tether is holding the bottom part of the trunk in place, so it's not able to bend and move, and so it remains quite spindly. And if we leave that tether on for years and years and years, what happens over time is that that top part of the tree is still able to bend and move with the wind, and so that top part will become quite thick and chunky in comparison to the lower portion of the tree. So that when we do take off that tether, if we take it off too late, then what happens is the tree is pretty top heavy and it runs the risk of breaking and being damaged much, much easier. So what we really want to do when we have young trees is only tether them just until the roots take hold. It's just enough that they're not going to get uprooted or completely, laying on their side in the wind or anything like that. And then we want to remove those tethers and let that tree start to thicken on its own. Otherwise, we're completely limiting its chance of survival. So we think we're helping it, but we're actually hindering what it needs to do to be able to grow big and strong. So this wind, this 40% of the wind that's going into our forest, it only goes until you are 1 kilometer into the forest. At 1 kilometer into the forest, there is no wind. So what's happened to that wind is that essentially that forest has taken all of that energy from the wind and turned it into wood at this point. So when we look at our agriculture today, we know that there's definitely a deficiency in trees. We have a lot of grain monocrops, things like wheat and barley and such, that is very, very deficient in trees. And what we notice because of the lack of these trees is that we're missing out on the stabilizing and the energy generating potential of having a forest. We just don't have that same stability without having a forest in place. And when we have trees that can relate to other trees and communicate with other trees and can connect to other trees, we end up stacking time and space events into stable, productive permanence by playing around with the combinations of these trees and placing them next to landscapes that can benefit from them.